Today's lesson is on trigonometry, which I will always refer to in short as trig. It's very fun when you learn how to do trig, so let's just get started. All right, to determine the measures of all three angles and the lengths of all three sides is known as solving a right triangle. So if you got a right triangle and I say solve this triangle, it means I want you to tell me what all the side lengths are and all the angles measure. And we're going to learn just in a minute how to use trig to do that. Okay? A ratio of the lengths of two sides of a right triangle is called a trigonometric. And again, we're going to call it a trig ratio because that's just too hard to say. Trigonometric. It's a trig ratio, a ratio of the lengths of any two sides of a right triangle. Okay, so now we're going to tell you what the trig ratios are. The trig ratio relating the length of the side opposite, and this angle A here, we could pick any angle except the right angle. We could pick any of the other two angles. We're just picking A. So we have this picture down here. We have this picture, so let me do this. Let me draw this up here so we can refer to this diagram and I don't have to keep scrolling down. Let's see, I got my right angle at C. This will be A. This will be B. And so, of course, I'm going to name my sides across from the angles with lowercase letters. This will be little b, that'll be little a. Okay, so now I can fill in these blanks without having to go back and forth. Okay, so we're using this angle A here, so we're going to call that our reference angle for setting up our trig ratios. If we're talking with respect to a certain angle, that's our reference angle, and we're using angle A for these three definitions. Okay, so it says if I relate the opposite side, so that side over there, to the hypotenuse, that's called, and I've used up my blank, that's called the sine of angle A. The sine of angle A, side opposite, and we abbreviate it sin. We still call it sine, so please don't call it sin. It's not a sin at all. It's not even close to being a sin. We just abbreviate it with sine A, and based on our picture, that's going to be side opposite over hypotenuse, right? A over C. All right, the trig ratio that relates the length of the side adjacent to angle A. So adjacent to angle A would be this one right here. Okay, C is also adjacent to A, but it's the hypotenuse. So we're never going to use the hypotenuse as the side opposite or the side adjacent. So adjacent to A over the hypotenuse, that's known as the cosine of angle A. And we're going to abbreviate that COS, A, cosine of A. All right, and in our picture here, the side adjacent to angle A is B, and the hypotenuse is still C. Okay, and then we've got one more, the trig ratio that relates the length of the side opposite. So let me do that one with red. The side opposite angle A and the side adjacent is known as the tangent. The tangent of angle A, and we like to abbreviate that tan A. And in our picture here, that's going to be side opposite would be A, and the side adjacent would be B. And that follows with the little picture I had down below. I just drew it above so we didn't have to keep scrolling up and down. Okay, so you have to remember those three ratios. We will use those time and time again. And here they are all put together. And look at this. Look at this little thing here. It says, remember Sokotoa. Well, you should remember Sokotoa because he was a great Indian chief. You may or may not have heard of him, but more important than what he did as an Indian chief is that you can use his name to help you remember the ratios, right? If I've got Sokotoa, S, that's opposite over hypotenuse, right? S-O-H, and then Sokotoa, that's cosine, that's adjacent over hypotenuse, right? And then the T, the TOA, that's opposite over adjacent. So you got all that right here in this handy dandy little box. You definitely should have already made yourself a flashcard. No way around it. You got to remember these ratios. Let's see now how we're going to use those. Okay, here we go. It says find the sine, the cosine, and the tangent of angle P. So here's angle P. I'm going to mark it. Remember, that's my reference angle. I'm going to start out with sine. We're going to use our abbreviations. The sine of P. What did we just learn? Well, sine is side opposite over hypotenuse. What is the side that's opposite P? It's 15. What is the hypotenuse? It's 17. So there it is. That's the ratio. That's the sine of angle P. All right, let's do the cosine. The cosine of angle P is the side adjacent, which is 8. The hypotenuse still 17. And the tangent of P is going to be side opposite over side adjacent, which would be 15/8. There we go. That's all there is to it. Have to remember your ratios. All right, let's look at this next one. Find the sine, cosine, and tangent of 60 degrees. All right, well, the 60 is right there. There's 60. There's my reference angle. So the sine of 60 is going to be the side opposite, which is the square root of 3, divided by the hypotenuse, which is 2. These are some ratios you'll have to know by heart when you get to pre-calc and start learning the unit circle. All right, and then we need the cosine. Cosine of 60. And sometimes I don't put my degrees there. That's okay in this one instance because that's not our final answer, right? So the cosine is side adjacent. Side adjacent to 60 is 1. The hypotenuse is 2. And the tangent of 60 degrees is going to be side opposite over side adjacent, which is going to be the square root of 3. Okay, that's how we use trig. Okay, now, how about you pause here, because I've done a couple. I want you to pause and find the trig ratios for angles x and y in this problem and come back and check. Okay, so here we go. I started with angle x being my reference angle. For the sine, I got to get the side opposite over the hypotenuse, 16 over 20, and guys, you do have to simplify these ratios. You can't leave it as 16 over 20. You got to simplify it down to 4/5. Okay, the cosine of x would be the side adjacent, which is 12. Hypotenuse is 20. That simplifies down to 3/5. And the tangent is side opposite over side adjacent. So that would be 16 over 12, which simplifies to 4/3. And then when I'm looking at angle y, I got to use angle y then. Here's my reference angle. So if I want the sine of it, I got to get the side opposite divided by the hypotenuse. That's 12 over 20, which is 3/5. The cosine of y is the side adjacent, which is 16 over the hypotenuse, which is going to give me 4/5. And then the tangent of angle y, the side opposite is 12. The side adjacent is 16. So when I simplify that, I'm going to get 3/4. Okay, so you may be asking yourself this question now. Okay, well, if I look at this picture here, okay, I know the sine of x is 4/5, right? That's what I just got from this triangle, but I want to know what that actual angle measure is. What does that angle measure if its sine is 4/5? Well, this is where inverses come into play. So if you know the sine, cosine, or tangent ratio for an angle, which is what we've been looking at this whole time, you can use an inverse to find the measure of the angle. So let's just do this one. Okay, you're going to need your calculator now. So everybody get your calculator out. I'm going to go grab my calculator. And let's see here. Here's my calculator. The first thing we have to do is everyone needs to press your mode button. You see, here it is on my calculator. It's red. Yours isn't red, but everybody press mode. And you see, if you scroll down, you can use your cursor to scroll up and down. I need to scroll down to this line that has radians or degrees. I have to make sure I'm working in degrees, so use your cursor, go over to degree, press enter, and now you've set your calculator to degrees. It's very important to remember that whenever you clear your calculator, it's going to default back to radians. That's its default setting. So every time before your test or quiz, you've got to put your calculator back in degree mode. Okay, so once we have it in degree mode, we want to quit. So you see how right above mode it says quit? So anything we want to do that's in blue, we use the second button and then we hit that button. So we want to get out of there. So you remember what we were looking at in the previous problem was sine x equals 4 over 5. So the way we use an inverse is we're going to say the inverse sine of 4/5 gives me the measure of that angle. All right, so that's what an inverse is. When I know the trig ratio relating to sides, if I take the inverse of that ratio using that specific trig function, I can find the measure of the angle. So if you see your 3 trig buttons kind of about a third of the way down on your calculator, you see sine, cosine, and tangent. We want the inverse sine. Well, you see how the inverse sine is right above sine, so we're going to go second sine. We should have that there. And then we want to put 4 divided by 5 in our parentheses. 4 divided by 5, because it's 4/5. We got to close those parentheses. We're going to hit enter, and that tells us that that angle there is about 53 degrees. So let me go back over here. So this angle X, I'm going to say, is approximately 53 degrees. I'm just rounding it to the nearest degree. Okay, so that's what an inverse is. So let's look at that a little bit more so we get comfortable with it. So it says, solve this right triangle. Solve, remember what I told you? That means find all the missing side lengths and all the angle lengths. Okay, well let's just find side C first, because we're just going to use the Pythagorean theorem to do that. So we know that C squared equals 4 squared plus 8 squared. Therefore, C is going to be the square root of 16 plus 64. So C is going to be the square root of 80, which is going to be 4 times the square root of 5. So there's what C is, 4 times the square root of 5. Now that we have all of our side lengths, we can use all those with some trig ratios to find the angle measures. So why don't we just start with angle A? So we can use any one of our, we can use sine or cosine or tangent because we have all 3 of the sides. So let's just use sine. So the sine of angle A is the side opposite, which is 8, over the hypotenuse, which is 4 times the square root of 5. Okay, now, I know you have a strong desire at this point to simplify that ratio, but since we're going to just punch this right into our calculator, I'm not going to mess around with simplifying it. What I do have to do to find the measure of angle A is take the inverse sine, right, of 8 over 4 times the square root of 5. And it's okay, since we're going to punch it in, that we don't simplify that, okay? And then, but we're going to have to round this off because it's going to give us a decimal. So let's round it off to the nearest tenth. So I'm going to do inverse sine of 8 divided by 4 times the square root of 5. So let me go find my calculator back in here. So I'm going to do inverse sine. Remember, second sine. And what did I have? 8 divided by 4 times the square root of 5. And I need to close, yeah, I need another parentheses there. These parentheses get fishy, so guys, please remind me in class. I'm going to show you how to set up what's in your parentheses as a real fraction, so you don't have to worry about all these parentheses. Don't let me forget. Okay, so there we go. The inverse sine of 8 divided by 4 times the square root of 5 is about, what did we say, round it to the nearest tenth, so about 63.4. So this measure of angle A is about 63.4 degrees. Just going to label it there. Okay, so there's the measure of angle A. Now, if we wanted to, we could just add 90 to that and then subtract that from 180 and get the measure of angle B, but since we're trying to learn trig, I want you to pause. Well, no, you don't have to pause. I'll let you do the next one. Let's find the measure of angle B by using tangent. How about this? So the tangent of B equals side opposite over side adjacent, right? So the tangent of B is 1/2, and I am simplifying that one just because it's easy to simplify. Okay, what do we know? We know that it better come out to be something like 27.6, because, right, these two have to add up to 90. Remember that. Let's don't lose our ability to be logical. We know that when we take the inverse tangent of 1/2, we better get something close to 27.6. So let's see what we do get. Inverse tangent of 1/2. So we're going to go second tangent and 1 divided by 2, close our parentheses, and we get 26.6. 26. Oh, yeah, you know why? Because this plus this doesn't equal 90, it equals 91. So 26.6 is what I should have gotten, not 27.6. So thank goodness I used trig, otherwise I would have missed it on my test because I don't know how to add. So 26.6 degrees is about the measure of angle B. Okay? All right, now I want you to take a minute, look over what we've done, and you try to solve this problem that we have right here. Come back and I'll have the solution for you. Okay, so here we are. First thing I did is I wanted to find the measure of angle P, and that's easy because I know the other two angles in a right triangle are complementary, so I know that the measure of angle P has to be 37. Okay, and now I really could have picked, the 53-degree angle or the 37-degree angle as my reference angle, but you know, since I messed up that math in the previous problem, I thought I better use the angle that they gave to me just to make sure I don't make an error. So I used the sine ratio. The sine of 53 is the side opposite over the hypotenuse, so that's Q over 30. And then I just cross multiply and I get 30 times the sine of 53 equals Q. And then when I punch that into my calculator, I get about 23.96. Okay, and I'll have to tell you on your paper whether to round it to the nearest tenth or the nearest hundredth. I generally round to the hundredth if it's not specified. Okay, and then I'm going to stick with angle 53 because I know that's right. And then I'm going to use cosine, right? Because P, I need P now. Definitely do not want to use the Pythagorean theorem with these big numbers. So I know that P is the side adjacent to 53. So I'm going to use cosine. The cosine of 53 is P over 30. And again, when I cross multiply, I get that P is 30 times the cosine of 53, which gives me about 18.05 for that side length P. So that's how we solve a right triangle. So I bet you there's going to be another one over here for you to do. Let's see. Oh yes, another solve the right triangle. So I'm thinking this is probably a good point for you to practice all three of these problems. Just look back at your notes. I know this is new. I know it might be scary, but just take your time, review your notes, and try to do these next three problems, and then I'll put the solutions up for you. All right, I'm just going to let you check these answers. I'm not going to talk all through this because this video has been long enough already. Here's where I got A. A is right over here. This A, let me write it. A is 39. I did that work over here. I used the Pythagorean theorem. But what I asked you to please do is, now that we found it using the Pythagorean theorem, I want you to use one of the angles as reference and then use trig to find, sorry, not big A, little a. We want to find little a. Little a using trig. I want everybody to do that. I will look to see if you did it when I look at your notes next time. Use trig to find little a. See how close you get to 39. And then I just had to use my inverse functions to find the measures of angles A and B. And remember, they should always add up to 90. So that's 0, 0, 0. So those two do add up to 90 when I add those together. That's good news. All right, the next problem says find the measure of angle y. Well, the two sides I'm given relative to angle y are the opposite side and the adjacent side, which tells me I got to use the tangent. And then I do the inverse, and I get that it's approximately 68. Why did I round it to 68? Because it told me round to the nearest degree. This is where you guys will lose points on your test, is because you won't follow the directions and round to whatever I tell you to. All right, so there's that one. And then it says, does it matter which trig ratio you use? Does it matter? So, if we knew the lengths of all three sides, of course it doesn't matter. If I knew the length of the hypotenuse and those other two sides, I could have used sine, cosine, or tangent. Doesn't matter. If you don't believe it, find out how long PY is, use one of the other ratios, and see if you don't get the same thing. You will. Okay, and finally it says find the values of W and X, and I got to be careful. Now that I've learned trig, I don't just want to go trig crazy and use trig every time, because this triangle over here is a 30, 60, 90 triangle. So I want to keep remembering to use my easy stuff. I don't have to use trig. It's a 30, 60, 90 triangle. They gave me the hypotenuse, so I know W is the shortest side in the triangle, which means it's half as long as the hypotenuse. So that's how come we know that's 3. And then we want to find X, which is this little angle right here. So now we've got two sides. What do we got? We got the side adjacent and the hypotenuse, which means we got to use the cosine. I set up my ratio, then I got to do the inverse cosine, and I get 41.4 because they told me to round it to the nearest tenth. And that is your lesson on trig. Next lesson we'll be using trig a whole bunch more, because we're going to learn about angles of elevation and depression. And again, in the very last lesson, we'll talk about vectors. So practice your trig, and we'll see you next time.